In today's video, we're going to look at the shear and bearing failure of an aluminum plate, specifically an aluminum plate that has a hexagonal piece punched out of it by a steel punch. So the problem statement is that we have a mechanized production of hexagonal aluminum pieces using a steel shear punch. From the picture on the left, you can see that we have 25,000 pounds pressing down upon the steel punch, and the steel punch is then pressing against the aluminum plate that will then punch out the hexagonal piece. The first question we need to ask ourselves is, will it fail due to shear? So will it actually punch out the piece the way we want it to? Then we need to ask, well, will it fail due to bearing before it does that? So to start, we're going to look into the shear part of this problem. So the first thing we need to do is figure out the area upon which the shear force will act. So we're going to add up 6 of those red boxes you see in the bottom left, because that's the area in which the shear force will act. So it has dimensions of 1 inch by 0.125 inches. So the total shear area will be 6 times 0.125 inch times 1 inch, and that will be equal to 0.75 inches squared. Then we can find the shear stress by taking the force applied, 25,000 pounds, divided by the area that's affected by the shear force, so 0.75 inches squared. This will total to 33,333 psi. Now that is over the shear failure rating of the aluminum at 30,000 psi. Now, that's actually good because that means the piece fails due to shear. So that means the punch works the way we want it to. The last thing we're going to look at is the bearing failure of the plate. Specifically, we want to make sure it actually doesn't happen. We want to make sure that the plate is sheared to create the hexagonal piece and doesn't fail due to bearing before that happens. So our area is going to actually change. It's, instead of the side pieces of the hexagon, it's now going to be the face of the hexagon, shown in red in the bottom left. So the area of that will be comprised of 6 equilateral triangles with sides of 1 inch. And to get that, we'll just take 6 times 1/2 the base, which is 1 inch, times the height, which if you do a little bit of trigonometry, you'll find that it's 0.866 inches. And that'll mean that we have a total of 2.598 inches squared for the area. And then we do the same as we did before, and we find the stress acting on that area by taking the force divided by the area. So 25,000 divided by 2.598 inches squared, and we find that the bearing stress on this area is 9,622.79 psi. Now that's much less than the 88,000 psi that would be the failure point for bearing stress for aluminum. So because of that, it does not fail due to bearing, and that's also good. So we now know that our punch will work as we expected, and it won't fail due to bearing. So this was just a quick little problem showing you how to work with shear and bearing stresses and kind of how to think of what areas are being affected by each. And now you should be able to apply these to problems of your own.